Hello everyone, welcome back. Today we'll be learning about dynamic host configuration protocol DHCP. It is one of the most important concept in computer networking, and to understand how our electronic devices gets an IP address when we go to a public places where there is a busy restaurant or a cafe. How does our computer is how our computer or laptop or PC or any electronic devices that is going to be connected with the public Wi-Fi or our home Wi-Fi. So let's understand what is dynamic host configuration protocol. So before we move to the dry text definition about what DHCP is, let's understand the analogy of it. So basically what happens is, if you walk into a busy coffee shop and try to do some work, right, a remote work, to get online your laptop needs a unique set of number, which is an IP address internet protocol. So what happens is, if there is no DHCP, if there is no dynamic host configuration protocol, it's a static IP setup. So that means you'll have to call the coffee shop right before. So what happens is, this is a basic analogy. It's gonna be a static IP. So if you want a seat in coffee shop, right, so what happens is you have to call the coffee shop about ahead of time and say the manager that you have to you have to reserve the table for them, and hopefully nobody sits there, and if somebody does, then there will be an IP conflict. So basically with DHCP what happens is, it is automated. So you walk into the host, right, so you walk into the coffee shop and immediately you are shown a seat at a table 4, and you sit there and you are shown a restaurant, you are given a Wi-Fi password, and when you leave, the seat goes back to the other customer. So that is basically what DHCP does. We'll understand this with a proper concept of DHCP, but this is just an analogy how a DHCP helps you right, help us. So let's understand how DHCP works. So dynamic host configuration protocol. So let's understand how it works. So when somebody asks how does it works, we must we must mention DORA, which is a discover, offer, request, and acknowledgement. So this is a 4-step handshake, right? As a handshake, DHCP uses over a UDP port 67 and 68 client. So basically when you enter a coffee shop, right, so what happens is the DHCP needs to convey a message, right? So it's gonna use a pointless, or I mean not pointless, connectionless protocol, which is a UDP. It sends a message at a UDP over a 67 server and 68 client at a UDP port. So that's basically how it works. So let's understand what is discover. So what happens is, when a new device wakes up and shouts in the network like, hey, I'm new here, right, my MAC address is this, is there a DHCP server around, which is basically a router, I need an IP. So what offer does is, once the DHCP server hears the shouts, right, it looks as is available pool and replies, hey, I see you, right, I see you are a new device in this network. So it offers an IP address along with its default gateway, along with its server and all. So that is how basically a server offers it. So after client, it hears the offer, it requests, right, so client hears the offer, it accepts, it was awesome, I like this IP, right, I can work with this, please lock down this for me, and this is the broadcaster. So if there are other DHCP server, this offer, so if there are any other DHCP offer, they know that the offer has been accepted, and they stop it. So after acknowledging, right, the server finalizes the deal. You say you got this IP of yours for the next 24 hours, which is known as lease time. So here is your subnet max, gateway, and DNS. Everything is given to this. So this is how a discover, offer, and request acknowledgement is done. So this is the figure. So this is a DHCP client, this is the DHCP server. There is a discover, offer, request, and acknowledgement. So let's understand more clearly with an example. So first, discover. Obviously when we walk into a coffee shop, again same analogy, your laptop screens into the dark means your laptop activates its wireless card and broadcasts a message to the entire room. Why entire room? Because there's a reason for it. So the message sends us, hey, I just got here, I don't have an IP address, is there a DHCP server around here that gives me one? So basically your laptop sends a DHCP discover packet out of a UDP port 68, which is a client, right? It's a client part, because it doesn't know who the router is. It addresses it to the 255.255.255.255, which is a Broadway address. This is subnet marks. So every device on the Wi-Fi, network, hears this scream, but only the router cares for it. So after discover, if the offer patch comes in, the coffee shop router steps up. So the coffee shop router hears your laptop scream, right? It looks at its list of available IP address and picks one out. So the message it sends to the client is, hey stranger, I am the DHCP server here. I have an opening. How does the IP address 192.168.1.45 sounds to you? Right. The router sends a DHCP offer packet from the UDP port 67, which is a client, which is a server part, back to the UDP port 68, which is the client part. It includes the IP address, how long you can keep it, which is the least time, and a DNS server, so you can hold the website, load the website. So that is basically what happens. After that, the request, our client, your laptop locks it in. So your laptop receives the offer, it likes a number it sees, so it finally claims it. The message sends is, awesome, thanks, I'll take this IP 192.168.1.145. please lock this down for my laptop MAC address so nobody else can take it. So your laptop sends an DHCP request, even though it is talking to the specific router, right? It broadcasts the message to the whole network again. Why does it do that? We have talked before, right? We have said that before, because there are not only one DHCP server, not only one specific router, right? This is a polite way of telling any other router in the building, thanks, but I already found a server. So that is why basically it sends to all the devices, all the messages to the devices. Another is acknowledgement, right? The router marks 192.168.145 as taken in the database. The message you receive is, you got it, you are officially checked in, enjoy your Wi-Fi. So the router sends a DHCP packet. Your laptop accepts the configuration, assign the IP to its wireless card, and your Wi-Fi icon changes from connecting to connected. So that's basically how the device, there's basically this, the icon on your Wi-Fi device goes from see, what I do is connected, it goes to a due to the DHCP, it goes to connected. So that is basically how it works, right? So now let's move to the some of the interview question that may be a bit tricky, that you may be faced during the interview, right? So what is the DHCP lease time and what happens when it expires? We have seen this in our example analogy, how DORA works, right? So lease time was there. So what is a DHCP lease time and what happens when it expires? So IP aren't given forever, they are leased. Halfway through the lease, called T1 timer or 50% marks, the client automatically sends a unicast DHCP request to the server to renew it. If it fails, it tries again at the timer 2, which is 87.5 marks by a broadcast. If the lease completely expires, the device drops the IP. For system admin tapes, in an corporate office, a 7-day lease is great. In a high traffic public guest Wi-Fi, set to 1-2 hours so you don't run out of IP address, because there are multiple devices trying to get an IP address, right? So this is why if you are public place and you're trying to log into a public Wi-Fi, there are numerous devices that is already in the queue that is waiting for the IP address. DHCP that is waiting for DHCP server to assign them an IP address. That is the reason sometimes you can't connect to a Wi-Fi of a public Wi-Fi. So that is the reason, because due to the lease time. So another question is, what happens if a device requests an IP but an DHCP server is dead, right? If a Windows device can't get a DHCP server, it assigns itself, which is known as automatic private IP addressing. It assigns to itself. If you ever see a device with the IP address starting with 169.254.x.s, it means the device is talking to itself, because the DHCP server is completely unreachable or out of IPs. So This doesn't only happen to a Windows or Windows device, it happens to a Linux, any electronic device, Android, iOS. Let's see how different operating system or a different version they talk to itself if the DHCP is not there. In Linux, right, the behavior completely depends upon which network management software the distribution uses, but the core mechanism is called zero configuration networking, right? So modern Linux, if DHCP fails, modern distro will automatically generate a fallback 192.169.254.x address. Right, the tool that is used is basically AVI.AutoIPD or a built-in routine inside if it is using systemd.network to prove the network or safely claim a random 169.254.x address. So I mean, there are exceptions because like if you use CentOS from Docker, if there is a very minimalistic version of a Debian, or if you use that kind of Linux operating system, then DHCP fails because the interface simply stays down with no IP address, because there is no concept of active link local addressing. Link local addressing is same as APIPA. It is just a fancy Windows just use a different name, and local link local addressing is simply it is the process of assigning itself an IP address if DHCP is broken or if there is no sufficient IP address. That is basically it. So Mac OS, they are one of the most they actually pioneer it, right? So they call this implementation Bonjour, right? So formerly known as Rendezvous. I don't know how to pronounce this, but Mac and iPhone, if it fails to fetch an DHCP lease on a Wi-Fi or Ethernet, it will immediately drop into a 169, right, 254.x space. Apple relies on this heavily for local ecosystem like AirDrop, AirPlay, and local file sharing to keep working even if the home internet router completely crashes. So that is how they say, they have I don't know, AirDrop, they call it AirDrop. They can send data so efficiently. Another is for our Android and IoT devices. So Android device will assign 169.254.x address if DHCP fails, but the UI will usually pop up the warning saying like connected with no internet or switch automatically to mobile data. So that is how our device. Another is almost all modern smartphone or enterprise IoT, they have equipped local link local. If DHCP fails, it is exactly how you are able to plug a brand new IP camera directly into your laptop, right? Ethernet port, which cables and configuration it buys a web browser. So I want to explain a bit about this. So imagine you have a brand new camera and you connect with the Ethernet. We connect the camera with your PC. So once it does is there is already there is built-in local link, right, that is assigned to in camera. So once the camera is connected, then the camera has 169.254.1.20. And same as soon as you plug in the Ethernet, right, the PC knows it and it says it waits for a few seconds and says there is no DHCP server. So it's gonna assign to itself, right? So it's gonna assign 169.254.1.13. So once it is inside the same network, then the transfer of data or connection take place very very fluently within the camera and the PC. So that is basically how they can communicate with the camera configuration, say web, if there is a built-in web feature. So that is how basically it communicates. Another is what is DHCP replay agent. So by default, DHCP discover messages are broadcast and router block broadcast from jumping to one another. Routers block broadcast from jumping to one another. If your DHCP server sits in a central data center, you configure a DHCP replay agent or IP helper header on the local router. It intercepts the local broadcast, package it into a direct unicast message and forward it to the remote DHCP server. So by default, the discover messages are broadcast, right, and a router block broadcast from jumping to one network. So if a DHCP server sits in the central data, you configure a DHCP replay agent or IP header on the local router. It intercepts the local broadcast package and directs a unicast message and forwards it to the remote DHCP server. So basically sends to the DHCP server. So another is a real world configuration. So basically you must understand what the scope means. So example, IP pool. So this is 192.168.1.50 to 200. This is basically IP pool that can be used, that is passed to the integrating devices, right? Another is exclusion. So this is the scope. So 192.168.1.1 to 49. So this is basically, this is saved for the static assets, so server, printer, firewall. Okay, these are not used by the electronic devices, but I mean for the server, printers and firewall. So from 1 to 49, these are used for the static assets, right? So another is subnet mask. So that is basically tells the device who it is, who is on its local or outside, local street or outside. So it tells the device who it is on, right? Another is default gateway. So basically it is like a door to the internet, right? Another is DNS server. There is a phone book to translate the names like google.com to IP. So basically DNS server, it translates the names like google.com to IP. So basically that is used. So this is it. This is how you this is how a DHCP works. So I hope you understand a bit. I know this is a bit confusing topic, so if you have any question, I am more than happy to help you in the comment section if you have any questions. So I'll see you in the next video with a new topic. So hopefully stay tuned. Thank you.